Hello and welcome to another video series about building something for a home lab. And in this video series, we're going to build some home lab stuff using a little mini rack. And these mini racks are sort of all the rage in the home lab community. Jeff Geerling has some fantastic videos that I'll link below on the different versions of these. This is made by DeskPi, and it's a 10-inch wide rack, so sort of a shrunk version of the typical 19-inch rack. And they have three different height versions. This is the larger one, that's the 11U rack. And it's been kind of a fun project to figure out what you could build and put into one of these little racks. So we're going to build a little self-contained home lab in this rack today. And we're going to try to make it something that is more performant, which is sort of in my favor. And so as far as the hardware platform goes, we're going to use these Miniforum MS01s. And these are a well-discussed topic in both YouTube and on Reddit. They're very popular in the home lab community. And if you look on Reddit, there's a person who maintains an Excel spreadsheet of these Miniforum PCs. And I think there's maybe 500 or 1,000. There's a lot of them in there. And if you take that list, and it's a very detailed list of all of them and the capabilities and features, and you eliminate all the ones that don't have a 10 gigabit interface, the list gets surprisingly small quickly. There are a couple of other versions. There's the Intel Extreme NUCs, which are crazy expensive. And then the Miniforum ones really stand out. And this MS01 is a very small compact chassis, and it comes with two 10 gigabit SFP plus interfaces, plus two 2.5 gigabit Ethernet interfaces, plus two USB 4 that are capable of 25 gigabit connection, HDMI, USB, all that stuff. But there's a little more to the actual chassis itself. It comes apart in a really interesting way where you pull a tab down and it slides apart. And then you can pretty easily get to the inside of it. And let's go over here to a little one sitting on the desk and we'll take a look at what's inside. So there's a PCIe Express slot here. So you can put in a small card, not a particularly large one, but you could put in a small card. It could be a small GPU. Not a tremendous amount of power capabilities, but certainly you could do that or a more advanced networking card. Underneath the fan with these three screws, there are two DDR4 DIMM slots. I have two 48 gigabyte DIMMs in each one in all of these machines, which is 96 gigabytes of RAM total. And that, I think technically they only say they support 64 officially, but the 96 does work. You can get this chassis with three different Intel processors, the Intel 12600, the 12900, and the 13900. Each one is successively a little faster and a little more cores and a little more power and a little more cost. But I verified that all three of those processor variants, they can all do the 96 gigabyte configuration, which is really good for something like Proxmox, having a little more RAM available. On the other side, there is a little fan shroud here, and there are four M.2 slots. The first one is one keyed for a Wi-Fi, and there's a little Wi-Fi adapter in there. And then the next three are made for NVMe SSDs. Perhaps the one odd thing about the chassis is that the slots are not all the same speed. The first one here is PCI Express 4x4, this is 3x4, and then 3x2. And this 4x4 slot is also special in that they include with it a little adapter to do a U.2 SSD and a little switch here to switch that on. Be very careful with that switch because if it's set to U.2, it puts higher voltages on a couple of pins here and it will fry a NVMe SSD if you have it set wrong. So make sure you don't change that switch or you verify it's in the right location. So you could put in a U.2 SSD of a reasonably large size and have it inside this chassis. The one downside of the three slots being different speeds is if you put in three NVMe devices and you want to use them in a, let's say, a ZFS RAID Z configuration, your speeds are a little bit unusual in that one is much faster than the others. I did test this pretty extensively with ZFS and it works fine. It on net performs, close to the performance of the slowest one, not exactly. But there were no other consequences of one of the drives being slower than another one, except for, of course, you just don't get the full performance you could get if all three of them were PCI Express 4x4 and your SSDs were fast enough to use that speed. I think you could downclock the slots. I think there's some other videos where people have downclocked them to make them equal, but I don't think it's necessary. Other than that, though, it's a great little chassis, very easy to add a little expansion to. And so we're going to use 4 of these, actually. So we're going to have 3 of them in a 3-way Proxmox cluster, and then we're going to have a 4th one that serves as a network-attached storage. Now, the idea behind having a 3 Proxmox cluster in sort of an HA configuration is really good because you can have one of the clusters fail and one of the other 2 machines can take over those virtual machines and run them. You can migrate VMs between clusters, but it all depends on the storage. So if we have 3 Proxmox nodes and then a 4th one serves as the network attached storage, if that NAS goes down, everything's gonna stop. And so one solution to that is to use Ceph, and it's very easy to use Ceph with Proxmox. And Ceph is a distributed file system where you can run a Ceph node, and we can run one on each of the 3 Proxmox clusters. And it combines all their storage together into this distributed storage. And the idea is that one of the nodes could go down, and the storage is still functional. And it works that way because it stores everything you write on all 3 nodes if you have 3 nodes. The downside is it's not particularly performant, in that, first of all, every time you write, you're writing to all 3 nodes over a network connection to the other 2, and all of them have to complete their writes before the write's completed. And as far as read performance, you're combating that write bandwidth usage with the read performance from one of the nodes. And so, in general, Ceph works a little better if you have more nodes. If you had 5 or 7 or 11 or 13 nodes, it can be much more performant. If you have a lot of nodes, then it's possible for a given write to pick the 3 machines that happen to be currently the least busy, as an example. And you can configure in Ceph how many minimum nodes you want to be written to, as an example. So you could have 13 nodes and have 5 of them be written to. And that can make the overall structure relatively resilient. So there's lots of ways to do it. So we're going to build this with a Ceph cluster using, I think we're going to start using the 10 gigabit interface for the Ceph network. But it's also possible to use the USB 4 ports, there are 2 of them per box, to make a little USB 4/Thunderbolt ring between the machines. And then you can run a routing protocol. There are a couple different ones. You can run OpenFabric's an easy one in order to connect them. And I'll have a link in the description. There's a great GitHub post that describes a couple different ways to configure it. And it's been evolving, and a number of people have been sort of leading that effort of how to make that work really well. And so we're going to give that a try. And if I remember correctly, you get about 25 gigabit a second of performance out of that interface. And so with Ceph, it's really important to have as much network performance as possible because everything has to go over the network to multiple nodes for any writes to happen. So we're going to experiment with using some of the VMs on Ceph and some of them on a NAS. We're also going to have a little firewall. So this is a little GTK, little NUC, and we're going to run OPNSense on this. These little GTKs are interesting. They have, I think, 4 NVMe slots. And there's a great video that Jeff Geerling did about this particular one. And I had actually tried something very similar, which is putting in 4 NVMe devices, and it did not work because it overheated like very quickly. He had discovered, that they lock up, and the heat is a huge issue. I think the heat sinks inside aren't even attached to the aluminum case, so there's really no radiation of heat. And so it's an interesting idea, but I think the thermal design on this is really, really limiting. And so using this as a NAS probably isn't a good idea. For the switching networking stuff, we've got 2 of these little MikroTik 10 gig SFP plus, 4 SFP plus port switches. These are really neat switches because they're relatively low power. You can actually power the switch with PoE, and it's 4 SFP plus with usual MikroTik, full configuration, VLANs, routing, all that kind of stuff. And they're relatively compact, so they'll fit well in this little rack configuration. And then I also have a little Ubiquiti 2.5 gig PoE switch. So to combine all this together, you can put it in the racks. There are a bunch of different 3D printing options you can make to build things. There are some commercial, where do I have one? Some commercial shelves you can buy that allow you to mount things. But there also are these really cool 3D printed designs for different devices. And so I found one for these switches in particular, and then a really nice 3D printed setup for the MS-01. So this holds 2 of them, and I have a couple of these. And the one thing I will add is that when you buy the rack from RackPi, it comes with relatively short screws, which are fine for the metal devices, but for the 3D printed ones, they tend to have much thicker flanges due to the strength of the plastic. And so it's worthwhile to pick up some 10, 30 seconds longer screws to use because the plastic is quite a bit thicker. And so with these pieces, we're going to try to start assembling in this all of the machines and the networking gear. And I also have a small UPS. It's a little APC UPS that'll fit in the bottom. I don't think there's any actual 10-inch rack UPSs available yet, but there are a number of UPSs that do fit. There's a couple trip lights and a couple APCs that will fit in the bottom here with enough space to be able to plug them in. And so this will be sort of a full form, UPS. I also have a little board here with 2 Raspberry Pi 5s on them, and so one of these is going to be running the monitoring of the UPS using NUT. That way, if the UPS goes on UPS power, because it wouldn't last that long with the UPS that small, it can auto shut down all the nodes, and then we'll have another one running some network monitoring and remote access software. So with that in mind, we're going to get started now in actually building this rack. All right, so we have the case is assembled. So we have the 4 MSO1s mounted in these nice little mounts here. The little GMK box for the firewall, the UPS. And then on the back side, have the little Ubiquiti PoE switch, the 2 10 gig switches, these guys, plus the 2 Raspberry Pis. And so now we're going to do some wiring. We'll do the network wiring first, plus the DAC cables. And then probably the most challenging thing really is the power routing. And the reason is just that the power bricks for these MSO1s is pretty large. They're kind of big. So I'm going to see if I can stick them into the side here and try to get it to all fit. So first we'll do the network cabling and see if we can get that looking correct. Okay, so I have the networking wired up. We've got the 2.5 gig ports from the MSO1s and the 2 Raspberry Pis tied into the Ubiquiti switch, plus the Pis are PoE powered, so there's no need to power those. And then an input to this Ubiquiti switch from the GMK, which is the sort of firewall, and then all 4 boxes are on one of the 10 gig networks, and then the 3 Proxmox nodes are on also on the second 10 gig network. And this enables us to have a 10 gig input as well as a 1 gig input. And then we are going to tie, let's see, we're going to tie this 10 gig switch into the firewall here, or the little Ubiquiti guy here. Okay, so now we have sort of basic networking. I'll get some little ties and tie these up. Maybe put these cables probably can go inside here actually to make it a little bit neater. And maybe these guys could be tied a little bit. They're pretty stiff. We could at least tie them to groups so they're out of the way as much as possible. But that's all the networking. So everything's hooked up. Now comes the more routing difficult problem, which is the power. A couple quick things to note on the power. The Ubiquiti switch uses its own little power brick. The GMK uses a little power brick that has a USB-C, and Jeff Geerling is the one who noticed this. This is like fixed at 19.5 volts. It isn't really USB-C regular PD. So do not plug this into anything else. It will blow something up. So I labeled it GTK only, not USB-C. And so we'll get this brick in there. I did order some like short power cables that go from the output of this into the UPS. So that should be a little bit neater. And then we'll work on the power for the MSO1s, which is by far the biggest thing to get stuck in here. So let's see if we can get that to fit in here. So. Okay, so now we have the power for the switches hooked up, routed down there, looks good. And the GMK is hooked up. Now it becomes time to figure out how to do the power for the 4 MSO1s. And I'm gonna see if I can grab those power cords and figure out how to do that easily. All right, so I got some adapters here to make this a little easier. The power cords that come with these bricks are super long, and we do not need that. So I have some very short ones, which, if I'm able to get the bricks to fit in here, could plug into a little small power strip. So that's an option. That'd be 4 of these cables going into a little 4 output power strip. So that is option 1 that could work. Another option is, these are 2 C13s into a C14. So in theory, we could take one of these and put it into this, and then have 2 power bricks with just 1 plug. Now we currently have on the UPS only 1 plug on the UPS side available. So I think I'm going to use a little power strip. The only problem is this has a huge cord, so I really should cut this cord and rewire it. But for now, it'll work. So then I just need to figure out where I'm going to put this cord at.
A few moments later.
Hello, welcome back to the now completed mini Homelab. So we have the case assembled with all of the components. We have the 4 MSO1s, 3 of them running Proxmox and 1 being the network attached storage. We have the firewall and the UPS. And if I spin it around to the backside, you can see obviously the MSO1s here, the 2 10 gig networks plus the 2.5 gig network, plus the USB 4 network that should be 25 gig. The little Ubiquiti switch here, plus the 2 MikroTik switches. The power bricks for the MSO1s I put on the side. It's possible to fit them in here. It's a little tight. But they produce a reasonable amount of heat. And so if I put them inside, that would be just more heat I need to extract. So it's a little better having them here, and then they plug into this little power strip that I made that goes right on the side of the case there. And so it still makes for a pretty neat and compact install. There's definitely going to be a need to add a little bit of air movement, so I'll probably add a fan on the bottom side of this plate here, and maybe a fan down here on the side to extract some heat. But it was easy to get it all assembled. Probably took about 2 hours total, so it's not a huge amount of work to lay everything out and kind of put it together. With everything running, so with the 3 Proxmox servers running, the 2 10 gig switches, plus the NAS firewall and the or the NAS itself and the firewall. It is around 130 watts, maybe 120 to 130 watts. And typically, if you run a number of applications, it can be a little more, up to maybe a couple hundred watts. But that's still reasonably good given the performance of those nodes. And certainly when you compare it to the 10 kilowatts in my real server room, this looks mighty efficient. It probably draws less power than the lights do in there. So it's been a really fun hardware build putting it together. And in the next video, we will go through the software and get the Proxmox and the Ceph configuration going, a little storage and firewall, and then also work on that USB 4 networking, which will require us to run probably the something like OpenFabric to do routing between each of the nodes. And so we'll get that configured and try to get that working over a fast network. And then we'll start deploying some apps on it. So stay tuned for the next episode, and we'll hope we'll have it up and running soon. Thanks for now.